Alright, this is lesson 69 for 7th grade, and today we're talking about the proper form of scientific notation. And what I want to do for this is go over 4 different examples with you. We talked about this today in class, and we didn't have a ton of time to talk about it, so we're going to cover this tomorrow too. But we want to get the main idea of what we're talking about here. And I've got 4 examples here. Make sure they show up. Alright, looks good. We've got A, B, C, and D. And we're going to find out that A and B kind of relate to each other, and C and D kind of relate to each other once we go through these. Alright, now the main goal here is to turn each of these into scientific notation, or at least the proper scientific notation. Because these 4 right now actually look like they are in scientific notation, but they're not. They're off by one thing, each of them. Remember, the first number in each case of scientific notation, or the proper form of it, needs to be 1 or greater or less than 10. So we have an issue here. This is bigger than 10. This is bigger than 10. This is less than 1, and this is less than 1. So we need to make these numbers so that they are in between 1 and 10. And then once we do that, it messes with our exponent. Because remember, powers of 10 tell us how many decimal places we can move our decimal. Okay? So right now, our decimal point is right here. 25.0, we could write that as. We need to make it so that it goes right in here. 2.5, that's between 1 and 10. Times 10, but that's going to mess with our exponent here. And remember, negative exponents to the power of 10 tell us to move our decimal to the left. Well, we already moved it 1 spot to the left, so that means that's 1 less spot we have to take it to the left here. So we're going to make this a -4. And this would be the proper scientific notation for letter A. 2.5 times 10 to the -4. Now let's just check and see if that gets us the same answer. Where's my marker? There we go. Both of these should be the same number. It's just that this one is more proper. This is the proper scientific notation. So let's see what this would be. 2.5 times 10 to the -4. That means we take our decimal and move it 4 spots to the left. 1, 2, 3, 4. 0.00025. We should get that here too. So this would be 25 times 10 to the -5. Our decimal is here, so we're going to move that 5 spots over. 1, 2, 3, 4, 5. And we do get the same answer. Yes, same number, but this is the proper scientific notation. Let's try that with B. Okay, same issue. Our decimal point is right here. We want this number to be less than 10, but bigger than 1. So 7.6 times 10. Alright, now positive exponents, they tell us to move our decimal to the right when multiplying by powers of 10. We are going the opposite way that it wants us to go. So we're going to add 1 to 4. And that should be 7.6 times 10 to the 5th. Let's see if that works out. 76 times 10 to the 4th. That is 4 spots to the right. 1, 2, 3, 4. So 760,000. Let's see if we get the same thing here. 7.6, 5 spots over. 1, 2, 3, 4, 5. And we do get the same answer. Proper scientific notation. Alright, now let's check our C and our D. These ones are less than 1. We need them to be bigger than 1, or at least equal to 1. They won't be when we move our decimal. So we want to move our decimal this way this time. 1 spot to the right. That's 2.5 times 10, and that's going to change our exponent like the other ones did. We are negative exponents times power of 10 want us to go to the left. We're going the opposite way. So we need one more place to the left that we need to go. So that's a negative 5. Let's check again and see if we get the right one. If we do this, that would be 4 spots to the left from where that decimal is. So 1, 2, 3, 4. And this would be 5 spots from where the decimal is. 1, 2, 3, 4, 5. And you can see we still get the same answer, except for now this one is in proper form. Alright? Now, letter D, our last one here. Same strategy, we want this to be between 1 and 10. So 7.6 times 10. And remember, our positive exponents to a power of 10 want us to move to the right. We moved 1 to the right, so that's 1 less spot we have to go to the right. So this would be a 4. And I'll leave it up to you to check that. These should come out the same if we went ahead and checked those like we did with the other ones. But what we should notice here is that when we have to move our decimal back or to the left, we are adding to our exponent. Notice how negative 5 plus 1 spot back gave us negative 4. 1 spot back, 4 plus 1 was 5. And if we move our decimal to the right, we are subtracting. So move it to the right once. Negative 4 minus 1 is a negative 5. Move it 1 spot to the right. 5 minus 1 is 4. So if you move it to the right, you are subtracting to get to the proper scientific notation. If you move it to the left, you will be adding however many spots to get it to the proper scientific notation. So that's the basis of what we talked about today, and we will be covering more of that tomorrow. Thanks.